in the context of playing God, you pointed out that it is possible to locate genetic disorders. There is a thought process which comes from financial markets which says that the human brain is constructed wrongly for current civilization. Many of the, much of the volatility that we see in financial markets, the root of the business cycle, is rooted, it comes from the fact that we don't know when we are thinking from our spine or the medulla, and when we are thinking using the cerebral cortex. Is there any work, there's a lot of work that is done at a philosophical level by behavioral economists, but I've read that neurology has started to work on this. Do you have any thoughts on this?
There's a whole series of ways to take that question. And the answer is, it's incredible how ignorant we are. When the first heart transplant was done, one of the studies that was carried out was bringing in the wife of the person who died to see if the man who received the heart was now in love with the wife. And we all laugh today, but for thousands of years we'd had this myth about he gave her heart, she broke her heart, I have my heart, all these stories and songs and tales, so it wasn't extraordinary to think emotion is actually in the heart. And now the last black box is the brain. And this question about how human beings act and what human beings do and why they act in certain ways and whether you can model the brain and whether you can model it as electrical impulses or biological impulses is one of the single most interesting questions. The stuff that we've been talking about is peanuts. This is single letter changes, single gene changes so far that have launched huge industries like biotechnology and changed the world. The stuff you're talking about is multiple gene interaction, multiple protein interaction. We are a long, long, long way from being able to model brains or understand this stuff, but it's probably the single most interesting area in places like MIT, where the neuroscience building is now going up next to the robotics building, which is going up next to the genetics building. And this interaction of the ability to bring those three fields in nanotechnology together is going to build some very, very rich countries and some very large companies.
There's a lot of work going on in terms of this whole area of neural networks, artificial intelligence, and this is all about modeling various kind of paradigms and seeing how neural networks interplay. So I think you can, but I think at the end of the day it's just too complex to try and work out how the human brain is going to react in a certain way. Suffice to say that human beings do have a herd mentality. So we tend to imitate, we do tend to copy what's going on around us.
The question is to both the panelists, both the speakers. One is that a compliment sort of thing that I was reminded of Richard Feynman when you were speaking, Professor Juan Enriquez. I don't know whether you heard of him, but to me he seemed to be one of the greatest brain in physics. I am a physicist, my name is Saxena, and now I work for a telecom company. But it was quite a mind-blowing experience when both of you were speaking. One was quoting Einstein, and one was quoting a whole lot of information science, which is basically material science and physics. See, the issue is that since 1990, we have been talking about a great change in genomics, biotechnology, and a whole lot of things. And I was surveying Silicon Valley, where people changed from software into genomics and biotechnology. Now, where are we? Have we reached some point, or are we still talking of science fiction? Are we in science fiction, or are we really doing something which will really change the world? One. The other is, if we have so much of knowledge of genetics, why don't we genetically modify the embryos so that there are no diseases? Why talk about the treatment and cure when we can do that with all the informatics at your command? And the third question, I'm sorry I'm asking too many questions, but I've been excited about this talk. The third question is, are you also using a fusion of nanotechnology and life sciences to really change the whole lot of situation? Thank you.
Well, I think in terms of the use of genetics and genomics, I can certainly tell you that there's a lot of usage of that today. A lot of the disease segments are being treated with a lot of this knowledge of genetics. For example, cancers today are certainly being looked at from that point of view, where a number of the new drugs are really based on the genetic evidence of the disease. a very good example of that is Herceptin, where we know that there is a very particular receptor which actually causes a certain type of breast cancer, and when you target that particular sector, that particular receptor, you can actually prevent and block that cancer from spreading. Now, a lot of this kind of genetic information about, like you just heard in Firoza's presentation, that people who had certain genetic disorders actually had almost a forewarning of what was going to happen. Today, biotechnology actually is relying a lot on genomic and genetic information, on protein expression and others to actually develop new drugs. In terms of producing designer babies that are free of disease, that's a long way because there's, it's difficult to even conceptualize that perfect baby. But suffice to say that yes, there are efforts to look and see how we can actually at least prevent certain diseases, like say the Down syndrome or Huntington's disease or whatever else, which we have a pretty clear understanding of what causes it, to see can we actually do something about it before the baby is born. Now, these are big, tough challenges, and maybe I'd like you to comment.
So let me see if I can tie this together with the question about the stock market. Is this stuff all science fiction? Not for those folks who invested in Kiran's company, right? I mean, there have been some pretty extraordinary returns already in some Indian companies in the measure that this stuff has its initial just baby steps. And as this stuff goes forward, people who are involved in insurance, in real estate, in chemicals, in textiles, in seeds, in food, in feed, in energy, are going to start feeling the impacts of this stuff in their mergers, in their acquisitions, in their structures, and in their investments. And I suspect that a series of your portfolios have already been changed in part by the ability to understand how life is coded, because this is moving all the way across the economy. The initial impact of this is very small. It's a little bit like the computer revolution. You saw it coming, you saw it coming, you saw it coming, and then all of a sudden it just took off. You're seeing the same thing here. And how it was launched actually is really interesting, because it was a physicist called Schrödinger who wrote a very small book called What is Life that changed most physicists into this field. So Watson was going to be an ornithologist. He read that book and changed. Crick read the book and he changed. And then there's a whole series of the great physicists that moved into this. And the reason why is because the dominant language of the 1800s, the way in which you became a dominant power, had to do mostly with chemistry and machines. In the next century, it had to do mostly with physics and the movement of mass and the movement of energy. And in this century, it's going to be life. This is the century of biology. And that's why you see all these physicists either moving off Earth into the universe and the study of the universe, or into things like biology, because it's the most interesting question sitting out there.
Drawing from your presentation on medicine, and then Juan's on that slide which came about on the business potential and how it has grown, and your question, Kiran, on are we playing God? What I want to ask is that putting all this together, obviously this is for the good, but is there some kind of a regulatory framework that society or government should be having, which actually encourages this growth and makes it happen the way we want it to happen? Are there some countries which are likely to have even a more competitive framework which would encourage the growth of this industry? And today, how do you see it? Do you see the United States or European countries or India or China? Which is that country that you see as having the most potential in making advances, both in terms of actual scientific advance, applications, but also in terms of growing the businesses and making very valuable businesses?
Juan, I think you'll be able to address this very critically.
So, one of the really interesting things about the UK is per capita, it probably has the best life scientists on the planet. This is a place that discovered DNA, this is a place that discovered penicillin, this is a place that discovered monoclonal antibodies, and this is a place that did cloning. And it has been absolutely unable to make businesses out of this stuff. All of it gets exported to the US, and everybody's very grateful because they build huge businesses over there, and the UK does very little. And there's this ethos in the UK and an even worse ethos in Europe of maybe we shouldn't do this and maybe we shouldn't do it for profit. If you don't tie academia to business, it's very hard to maintain a whole lot of the research institutions, a lot of the universities, if you don't have a tie between the IITs and the startups that you've had, or between the institutes of science and companies like Biocon. It's very hard for a country to develop, and it's very hard for those kids who are trained to have jobs, to generate wealth. There's some really big questions being asked in this stuff when you start playing with life. And it's countries that adopt the regulatory frameworks and teach their kids this stuff and get comfortable with this stuff that are going to do well. And in that sense, India may have a very significant advantage, not just because it has its enormous trained workforce and excellence in training parts of education. It may also have an advantage because, among other things, there's a significant belief in reincarnation. And when you can take cells and remake stuff, it is not inconceivable that your grandchildren are going to be running around this room or some other room at age 120 or 130 using a great deal of regrown body parts. And this is a society that may be a lot more comfortable with that than other societies, which may start opposing this, and those societies are going to fall behind. It's really important not just for businesses and countries to adapt, it's also important for religions.
I think the cultural acceptance in a country like India is far greater than in other parts of the world. But what we really need to focus on is, as Juan said, it's the innovation, the curiosity of discovery, and that's where we really need to focus. India needs to really focus on fostering that innovative mindset as well, apart from having the regulatory mindset to accept new and novel and, in brackets, sensitive technologies and therapies which are sort of perceived as being unethical in other parts of the world.
You know, there are three areas which really influences life of people, which is religion, science, and politics. And till last night, it was cricket also. Now, I got encouraged by your first slide, Kiran, when you said religion and science. I would put it, instead of religion, spirituality. Both the areas really work for the betterment of lives of the people. And the byproduct, of course, is the money also, because both are a multi-million-dollar industries, religion and science. My question is, do you think at some point in time, earlier there was a lot of conflict between spirituality and science. Do you think now they are working in tandems and merging at some point?
Well, I think, both are sort of inclusive of each other. I think science and religion, it depends on how you look at it, is certainly inclusive of each other. And that's why I said, you can have two schools of thought by saying that, okay, if there is a scientific rationale in everything that you do, then it's not spiritual. Whereas on the other hand, you're saying, look, the scientific rationale is really addressing a spiritual challenge. So, it just is an interpretation. It depends which school of thought you look at.
My question is to Dr. Mazumdar. Well, you said there are 40 million diabetes patients just now in India, and they are going to increase to 70 million by year 2025. Do you intend to say this, that it's an exploited figure, or is it after providing for the medicines which will take care of the immunity system of the diabetes, and still the number will increase? Is India working only on the medicines for diabetic patients, but not on the immunity systems?
I think the reason why they are forecasting this kind of alarming pandemic for even a country like India is because, type 2 diabetes is a lifestyle disease, and Indians do have a genetic predisposition to diabetes. And as our lifestyle becomes more sedentary and as our eating habits become, a type that sort of fosters diabetes, this is what they're extrapolating going forward. I think it's not about just medicines that we have today. I think the medicines that we have today can manage in treat the disease, but what we are really looking for are medicines that will reverse the disease. That is the challenge.